Hello, and welcome to videos for Chapter 3 review. There's going to be several videos, and you can kind of just pick and choose which ones you need to support you in your understanding. This video, we're going to start right here with question number 1. So it gives us this polynomial, which happens to be a quadratic because the highest exponent is 2, and they want us to write it in this vertex form. And so to do that, I'm going to factor out a 3 from the first two terms here and separate out the 1. And so when I factor out that 3, now I've got an x squared minus 2x, and we can actually rewrite this as a difference of squares. Remember, this is called completing the square. So to do that, I'm going to take half of 2 is a -1, and then I'm going to square that. So x squared minus 2x plus 1. I rewrite that. I am completing the square, which means I'm creating a quadratic that is a perfect square of x minus 1. Now, what I added, when I added this 1, I have to make sure I offset. So I've got my plus 1 already. So to offset that, I have to subtract that value, but it's actually 3 times 1. So I have to subtract 3 for that. So I have plus 1 minus 3. So this actually simplifies into 3 times x minus 1 squared minus 2. Where my vertex, then this is my h and my k. So my vertex is 1 and a -2. And because a is equal to 3 and it's greater than 0, it's face up. So this right here is a minimum point. My vertex is a minimum because it goes down and comes up. So we had to complete the square. We had to offset because of this 3 factored out. And then we rewrote it in the vertex form. And remember, it's always x minus h. So if this is x minus 1, then 1 is actually, h is actually a positive 1. So 3 or 4 new concepts all in that one problem. Okay, question number 2. It says, find the vertex and axis of symmetry of the parabola here, sketch the graph of f and find its range. So I am going to x squared minus 2x minus 3. I'm going to separate this out and complete the square again because that's kind of nice and quick. So to do that, I'm taking half of a -2 and adding 1. So it actually is similar to what was up front up here. So I'm going to add 1 and I'm going to subtract 1. I didn't have anything out front, so I just am actually adding the 1. So this separates or factors into x minus 1 squared minus 4. So my vertex is at 1 and a -4. And then the range, because a is a 1, we don't see it out there, but it's a 1. A is equal to 1, which is greater than 0. So it's again a face up. My vertex then is a minimum. So my range goes from the bottom of my y's, which is a -4 with a bracket around it, and goes up to a positive infinity. Okay, let's look at this video. The sketch a graph of this function, find the vertex, axis of symmetry, the intercepts, and the intervals on which the function is increasing and decreasing. Okay, so I'm going to find the y-intercept first. That's f of 0. So I'm just putting in 0 for x, and both of those multiply to 0. So we have a y-intercept at 0, 0. And it says sketch a graph. And we can do that just by our basic points here. It's a quadratic because the highest exponent is a 2. And a is 2. which is bigger than 0, so we know it's face up. And to find our x-intercepts, I'm going to set my function equal to 0 and solve for x. And I'm going to factor, I can factor out a 2x out of both terms, so I have x plus 3 left. So I can set 2x equal to 0 and divide by 2x equals 0. That's one of my x-intercepts at 0, 0, which is also my y-intercept. And then if I set x plus 3 equal to 0, x equals a negative 3. So that's another 0. 1, 2, 3. So there's another 0. And then to find my vertex, the h is the opposite of b over 2a. It's actually just b over 2a. So that b is 6 over 2 times 2, because a is 2. So it's 6 over 4 is 3/2. In my mind there, it is the opposite of b over 2a. So it is a negative 3/2. It's a negative 3/2, so negative 1.5. And then I'm going to put that negative 3/2 back into my function to find out what the output is. So 2 times 3/2 squared plus 6 times 3/2 is 9/4, so 18/4 plus 18/2. And that is equal to 18/4 plus 36/4 is 54/4 is really, I made a mistake because I should be putting in a negative 3/2. So that one is getting squared, that won't matter. This was a negative, so I should be subtracting this and subtracting that. So it's really a negative 18/4 or a negative 4.5. So that means I'm going to a negative 1.5 and down 4.5. So it's somewhere around in here. So my vertex is at a negative 3/2, comma, a negative 18/4 or a negative 9/2. So it's somewhere down here. So it's going to look something like that. And you can validate that in Desmos. And then the intervals where it's decreasing is from a negative 1/2 to infinity, and it's decreasing from a negative infinity to a negative infinity to a negative 1/2. Catch me back for another video.